So I'm really excited about tonight. I don't know if anybody's going to the BattleBots event tonight, the after party. For me, it's a little bit love-hate. Love the concept, hate that robots get broken and damaged and whatever. Because I'm here to talk about how do you scale robots and how do we get more robots accepted into the world. So excited to be here, and we'll get going. And of course, I went wrong. So my name is Tom Ryden. I'm the executive director at Mass Robotics. And I'll talk a little bit more about Mass Robotics later, but we run an innovation center that supports, right now, I think we're 64, 65 companies, all doing things in robotics. So we have a great insight into what's happening in the industry. And I want to share a little bit of that and then talk about how do we scale. So our definition of robots, if you've been to many of the talks here, during the week, you've heard people talk about what is a robot. We have a kind of a unique definition for us. We look for three main things. We look for mobility, and when I say mobility, I'm not talking about a cellular phone or anything like that. We're certainly talking about motors, actuators, the ability to get something to move, sensors, and then, of course, onboard intelligence and the ability to react to those sensors. So that's a pretty broad definition. And so when you look at our companies that are at Mass Robotics, they vary anything from agricultural drones to exoskeletons to 3D printers, which we actually consider a robot in the way we define it. And I want to share a little bit of insights on what we're seeing from the companies we work with and what's happening in the industry. So why should you be interested? The market now is projected to be about $200 billion by 2025. Give you a sense today, depending on whose numbers you look at, that's between 30 and 50 billion. So basically a 4x in the next 3 years. That's a tremendous amount of growth. Also, the impact that robots are expected to have on the global economy in the same time frame will be over $1 trillion. So that's a combination of increase in productivity, decrease in labor costs, things like that. But when you get to those kind of numbers, that's a serious industry that people are getting very involved in. So when we look overall at robotics, we see a number of different areas that companies are focused on. And I'm going to go into a little bit detail on each of these to give you a sense. And I'm going to include some data just so you get a kind of sense of growth, estimated growth and size. But together as a whole, robotics is an incredibly rapidly growing industry, and one that hopefully you'll be involved in. You'll have companies that will want to start and scale in this industry. So in terms of manufacturing, it's certainly the area that is traditionally known for robotics. Robotics have been on the assembly line of cars for many decades now. And that's traditionally what people think about when they think of factory automation. But we're seeing changes in that. We're seeing a lot more flexibility in automation, so collaborative robots. And then we're also seeing just different ways that robots can be used beyond what you see in assembly, but supporting the entire manufacturing infrastructure. So delivery of goods, prepping parts, painting, all the way through, everything you see in a potential site. And again, I'm not going to go through the statistics that are on the slides, but they're just to give you a sense for what people are expecting these different markets to be. So in terms of what we see in our innovation center around robotics, they fall into a couple of different areas. Collaborative robotics, probably the largest. We have a lot of companies working on the deployment of collaborative robots, either building a collaborative robot themselves. And if you don't know what a cobot is, it's basically an industrial arm that is human safe, that depending on its design, but it basically allows you to work side by side that arm. So we have a lot of companies who are working both on the arms themselves, but on the accessories and the ways to install these robots so that they become much more capable and much more easy to deploy and install, which opens up the market. It allows small and mid-sized manufacturers greater access to these tools, and we're seeing that show up in the numbers that are growing. We see a lot around the manipulation. That's the end effector. So soft robotics is one area that has certainly grown. We have a company called Ubrios that is doing soft gripping. Soft gripping allows you to pick up objects that traditional grippers cannot. And certainly this is valuable in manufacturing, but also in other industries like agriculture. I'll mention that a little bit later, but picking of soft fruits and things like that so you don't damage them. That's a great area. And then another is the ability to high-speed, rapidly plan the movements of the arms and then coordinate them with multiple arms. So have multiple arms moving very rapidly without collisions and avoiding humans. And part of the way they do that is through this workplace mapping, the ability to understand what a human is doing in the manufacturing floor, what the robots are doing, and then make sure that there is no possibility that the two will ever come in contact with each other. There's a company called Veo and a few others that are doing this, that are really using different types of sensors, building their own sensors to really map out that manufacturing floor. And then I think the other area that we're seeing, and I mentioned cobots, but specifically on cobots themselves, is they right now make up a very small portion of the overall market. 3 to 5% of industrial arms are cobots. And that is expected to increase dramatically. Number of reasons, I already mentioned some of that, but we're seeing like Universal Robots, which is right now probably the most popular collaborative robot. In the picture you see, that is the gray and blue part of their robot there. They've sold over 50,000, 55,000 I think now. And that's really only sold in the last couple of years where they've seen that. And so we're seeing a huge amount of growth in this. And as I mentioned, the interesting area is the cost to integrate. So when people traditionally install robotic arms, it's been about a third to two-thirds, a third being the equipment costs, two-thirds being the installation and support costs. And so when you're looking at a $50,000 arm, all of a sudden your entire package is $150,000. So we're seeing a lot of what we call lean integrators, or people who are installing these for significantly less and supporting them for significantly less. And then there are also software that allows virtually anybody on the factory floor to control these arms, install them, reprogram them, which is a big issue in small and mid-sized manufacturers. They don't have a long enough run to install these systems permanently. They might be doing one job, then they're going to transition to another job. If they need to bring the integrator in to help them move that robot to the next job, they can't afford it. And so new technology is being developed in that. Certainly not surprising in logistics. We're at an Amazon event. I think you've all heard other speakers talk about what's happening. I think if you attended Ty Brady's talk, he announced 2 new platforms that Amazon is releasing within their systems to improve logistics. We see a number of startups in this area, and they're getting significant funding to really address the challenges that I think people are well aware of. AMRs, autonomous mobile robots, probably one of the fastest growing areas, and then also different ability to manipulate, to pick. So picking still is a very challenging problem, mostly done by hand. In all of these automated system sites, you'll still have the human do the picking, but the robot takes away the movement of the goods. So that increases efficiency, but still picking is a challenge, and that's where a lot of companies are focused to see if they can come up with better, more efficient, more intelligent ways to pick. The market in terms of logistics, we talked in some in manufacturing, but the amount of investment in logistics robotics right now is really pretty amazing, and also the amount of activity. So here's a couple of points just to give you a sense. Locus Robotics, which makes a warehouse automation system, they just announced that they're sold 2,000 of those to DHL. And as a small company, Locus is still pretty young. That's a huge order for them. And then we look at some of the other ones. Berkshire Grey did a SPAC, as well as Symbotic. Symbotic is a total automated storage and retrieval system. And they have Walmart as their major customer. So you look at these kinds of deals and the VC money that has been invested, and you can understand why people believe that this is certainly one of the largest industries within robotics. Transportation and delivery, I'm not going to talk a lot about that. You certainly have heard about autonomous vehicles. We really are interested in the other non-traditional ways that people are addressing transportation. And so the picture on the lower left, that is the Gita, or Jita, depending on how you pronounce it, from Piaggio Fast Forward, PFF. There's actually, if folks haven't been to the tech showcase downstairs, there's one of these running around, as well as the picture on the lower right. That is a personal mover for airport applications. So there's a lot, as people get older, more challenged to get in these bigger and bigger airports. How do they get from the curb to the gate? And this is a fully autonomous transport system that allows people to just plug in where they're going, what gate they're going to. It knows how long it's going to take there, and it can path plan and get them to the gate in the proper amount of time. And also allows them to select things like, oh, can I stop for a cup of coffee before? And it will direct them there and so forth. They are also downstairs on the floor if you want to talk to that company. As a section of transportation robots, we certainly see delivery robots. There are many, many companies trying to address this problem. Biggest reason is it is a significant portion of the cost of an entire delivery of your item that you order from Amazon or whomever. Their cost, almost half of that goes into what we consider the last mile, from the truck to the door or to the apartment or to the office. And one of the ways to address that is certainly with delivery robots. A lot of companies doing that. Amazon's got their Scout, and there's a number of other platforms. And that's, we think, is a very interesting area for startups. No one yet dominates that area, and so there's the ability for startups to get involved in that. Agriculture, interestingly enough, we're based in Massachusetts. Not a lot of agriculture in Massachusetts. You know, we have some apples, we grow some cranberries, but not huge agricultural fields, and yet a lot of the development's done, primarily because the technology is coming out of some of the universities. But we see that in areas like field inspection for both use of fertilizers, water, pesticides, and then also ways to kind of monitor the growth and the health of the fields. There's a picture of a vineyard. Certainly they're doing other types of fields. I talked about picking before. That is an area that we continue to see a lot of companies develop some really cool technology on combining autonomous mobile robots with pickers to pick in fields or modifying orchards and so forth to allow robots to more easily pick. So construction is another industry that I would say is a laggard in terms of robotics. We certainly in Boston and in most cities, you're seeing cranes like crazy and construction going nonstop. But it's a hazardous environment. They are consistently behind schedule, over cost, and they do not use automation to the extent that other industries do. That's starting to change. We're seeing some of the major construction companies now invest in what they consider accelerators or innovation spaces, specifically targeted at construction. And they are looking at technology across the range of construction, from site prep all the way to finished construction. So one of the areas that we believe will continue to grow, it's still emerging, I would say. If you look at the numbers, and this is a projection, 7,000 robots. If you step back to the warehouse automation, I think Ty announced that Amazon Robotics has sold 520,000 of their AMRs. So you look at this number and go, all right, construction's got a long way to go. But because it's such a large industry, there's a potential upside here that's pretty dramatic. What are we seeing in that area? A couple of interesting things around kind of automating traditional things. So the picture on the upper right is an automatic demolition system. And there is some operator control, but there's intelligence on it that allows it to kind of better plan how to demo that concrete. Automatic bricklaying. The one on the lower left is a robotic painting system. Then that's actually painting in our facility. When we did an expansion, we brought them in, and they used their robot to paint a fair amount of our facility. And it's interesting because it's shown to be not only relatively fast. I will say you still have to do some masking and so forth. So it doesn't do everything that you would think in terms of painting, but it is much more consistent. And they've done a number of studies. They actually got hired by the Navy to paint a ship. And with the consistency of the paint is critical on the ship hull. And the robots can do it at such a greater accuracy. The cost savings was phenomenal. So I think they're kind of pivoting away from construction to shipbuilding. But I do see that opportunity in construction. They also use an incredible amount of AI to learn what they've painted and then optimize for the next one. So they're very good if you're doing apartment buildings or hotels where the rooms are fairly repetitive. Then they can learn, and you'll notice that the first room takes a while, but the second and third and then fourth, they go much faster as they paint. Inspection. Hazardous area inspection. It is one of the things, if anybody caught Allison's talk from Waymo yesterday, she talked about this is one of the areas that if you build your robot, she gave 4 areas that you should make sure that your robot addresses. If you address all 4, that's really great. One of the ones certainly is hazardous operations, because there's a real value to being able to take the human out and have a robot do its job. And so we see this, the picture on the right is a small ducted fan drone called Dronut, and it is very safe. You can see it, there's actually a gentleman grabbing it out of the air. But it's great for inspecting very narrow spaces, ducts, other things, where you want to get eyes on and see what's happening. And then on the lower left there's a picture of a company that's doing oil tank inspection. And again, another area you don't want to go into, these massive storage tanks. If you can send a robot in there to inspect the seams, the welds, and everything else, it's great, because you can really save lives by taking people out of those hazardous areas. Small but growing section. Hospitality. I think this one's kind of interesting because we don't see a tremendous amount of traction. We see a lot of interest. And so we see companies that are doing the delivery robots. So if you're in your room and you forgot your toothbrush, they can have a robot bring it up to you. And we're starting to see some deployments of those. There's also luggage delivery robots and other things that will help the movement, essentially movement of goods, much like the warehouse, within a hotel. There's work to do automation on the concierge side. I still think we're a ways away from there. I think still people want to have a human to interact with, but we know companies that are working on that as well. In the home, how many folks have a Roomba or another robotic vacuum cleaner? That's pretty good. Surprisingly, I'd say a little over half. I mean, some of you should go out and look at it. When they first came out, they were doing kind of a random walk. You would put the vacuum down, it would bounce around, and then over time, statistically, it would cover your floor. Today, they're much more intelligent. They have the ability to map and plan and avoid obstacles. In fact, iRobot just introduced their poop detection system. So the robot can avoid all sorts of different things that you don't want it to go over when it is cleaning. This is the iRobot S7, I believe, which has an evac system, so it automatically takes the debris out of the robot, and so truly the robot can just continue to do its operation for a very long period of time. So that's one area, but we see others. The picture on the lower left is a company called Ori. They're a startup. They are doing a robotic furniture. So this is furniture that transforms from a bedroom to maybe a dining room, or from a study to another room with a push of a button. So it has motors and actuators, has onboard intelligence, so it doesn't change the room while you're there or in the way. But it has the ability for you to have maybe a smaller apartment. And truly, when you're in your bedroom, you're not in your living room. And when you're in your living room, you're not in your bedroom. So why not use the same space for either? And they do that. They have a really neat system that has the bed that goes up into the ceiling. And then it comes down, the legs come out, the couch shifts, and all of a sudden you have a bedroom. So that's just another example of things that we're seeing in the home. I will say that one of the areas that we're interested in and we're following, although I think it's very early on, is the ability to get older people to stay in the homes longer. with technology such as robots, assistive robots, and so forth. Amazon has the Astro, I think it's called, and that's downstairs as well. They show one of those. But that's an example of these type of robots that are going to be in the home, that are continue to expand their capabilities and provide assistance to you. And whether it's turn on the lights, whether it's get you something, whether it's understanding if you have fallen, I think that technology is going to continue to grow. There are not enough healthcare workers to allow all these folks to go into nursing homes. People need to stay in home longer, and technology needs to help. And this is an area that we believe that robots can continue to do that. The robot on the right is a telepresence robot, and it's an example of just giving that presence, that physical presence in a home. It allows you can call into it. It's like video conferencing on wheels, so you call into it, your face appears on the front, you can drive around, and then you are in that location. So if you have an elderly parent that you might want to check in on or something, you can call into the robot and do that. Other countries like Japan are further along in some of the social assistive robots. Japan has Pero, which is a robotic seal. There's other technologies there that are helping as well as people cope with different stresses and strains through the use of tools that like the Pero. So again, another area. So what does all that mean, and why are we seeing this kind of growth in robotics? And why does it bode well for startups who want to get in and scale? We see a number of big trends that are really impacting the industry. Sensors being a critical part. Cost of sensors has come way down. I did a robot many years ago now. It was a bomb disposal robot and it had a camera on the front of it. And at the time, we were using a Sony block camera that was about $500. That same capability is $2 today. So in about 10 years, that price of that sensor has gone dramatically down. That's primarily driven by your cell phone, but the volumes have gone up on those cameras, costs have come way down. And that's true across many of the sensors we see. And that allows companies to embed more sensors across the platform to provide a better situational awareness and better performance on the robots. So that's big. Mobile manipulation. Right now, most of the manipulation we see is fixed. Most of the industrial arms are fixed. You're starting to see now some of the arms getting on mobile platforms. There's a lot of challenges when you add mobility to a platform, to an arm, in terms of both getting it to be as accurate as you need to be and having that platform be stable and repetitive in its location. But companies are working on that, and we're seeing that across all the industries I just talked about going to be a major player. Modularity and interoperability are two other things that kind of essentially go a little bit hand in hand. But the ability to take an arm from one company and a platform from another and combine them. Or a gripper, we do see that, but other types of elements of robotic systems and integrate them with others and make them easier to add, assemble, and understand as you do that. And we certainly have seen this in the PC world. It's not really prevalent in the robotics. They're mostly purpose-built and really constrained to what you get from that one particular vendor. But because the industry is growing so rapidly, we are seeing the ability to do that. There are no common standards in many respects to interfaces and things like that. One of the things that Mass Robotics works on is an AMR interoperability standard to kind of address that. To have the ability for a company to buy an AMR from one vendor and maybe a floor cleaning robot from another vendor and have them communicate so that they can understand where each of the different robots are. Each robot will build their own map, but the ability to communicate and overlay and maybe have a master plan or a master map so that people understand where all these different platforms are is going to be increasingly important. We see that as driving the adoption of the industry. Business models, robotics as a service has certainly taken off. We see a number of companies offering that. I'll touch a little bit more on that in a second. 5G communications better. And then lastly, we'll talk about cloud robotics, which is a major trend that's impacting robotics and the adoption and the ability for startups to scale at speeds that they haven't been able to in the past. Here's a little bit of why, and we're probably mostly preaching to the choir here, my guess is, that you folks know this. But building a robot is hard, it's expensive, and it takes a fair amount of time. And anything that you can do to reduce that is going to be beneficial. The ability to use cloud to take some of the onboard processing, offload it, so that you can build a robot that is less complex and yet still do the functionality you need. You're always going to need the kind of the real-time ODOA, obstacle detection and avoidance things. You're going to need that on the platform. So you're never going to be able to take all the compute power off. But if you can offload a section of that and run some processes in the cloud, that's going to allow you to make a cheaper robot that's going to be more widely adopted. Skills gap is another one. Hard to get talent who understands this. Great to leverage technology that has already worked through some of the challenges around deploying and connecting robots. I talked about RAS, and the way you can implement RAS is through cloud services. The ability to, and so RAS is the ability to not sell your robot, but sell the services or the solutions that it's providing on a per pick, per delivery, per whatever basis. And as I said, that's growing in interest, and the ability to do that is really driven by the cloud. The cloud gives you that, the infrastructure behind that. The other thing is scaling robots. It's one thing to deploy one robot or 10 robots on a factory floor or a warehouse floor. If you need to deploy 100 or 1,000, and how do you manage that? And how do you optimize fleet management? That is a thing that you can spend a lot of time and effort writing and programming, or you can use other tools to do that. So specifically, let me talk a little bit about AWS and some of the tools that they have that help you. So I think if you look at the AWS cloud services and capabilities, you're going to see that there are a number of advantages that they offer. We talked about agility, but you can use their cloud, and they have a series of robot-focused sections of AWS that really provide additional resources for you. So they give you the agility, they give you the cost savings, which is really interesting. You only need to pay for the services you use. So you can look at your roadmap and say, hey, I'm going to use this section of the cloud now, today, but in the future, I want to do some of this other work, and I want to be able to use maybe the fleet management system, RoboRunner, or some of the other packages. You can scale to that. You can also similarly scale up and down very quickly, add the resources that you need, and then deploy them pretty much anywhere you need. And as I said, you can use the expertise that Amazon has in some of these softwares that they've gained from their knowledge and use of systems like AMRs, and you can utilize that as you deploy and utilize their tools. One of the things that we were talking about today is how do you accelerate? And in an effort, we worked with Amazon Web Services, and we ran a robotics accelerator, the AWS Robotics Accelerator. We started it last fall and then had a cohort that ran this spring. And the accelerator was designed for young startups, primarily startups who have not raised significant funding. A little bit of flexibility there, but really you're looking for young startups who are getting going and who really want access to the knowledge and ability to use both cloud computing and other technologies to be able to scale their companies. So we had 70 applicants. We choose, I think, 20. I'm going to look to our AWS contact because he knows the exact number. But we selected 20 for the first cohort. It was a 4-week program. The program was a combination of educational instruction around how to use different services, and then introductions to the greater ecosystem of robotics. So we believe that it's really important to kind of, if you're a startup, to not be totally focused on your solution, but to understand what the industry is doing and what your other competitors are doing, what your customers are looking for. And so we provided a number of sessions around that. Introductions to investors, introductions to large corporates, and a number of other things. And what was really interesting was, as I said, we had 20 companies. I think 3 or 4 of them are here today downstairs showing theirs. And they all went through this 4-week process. And the results we got were pretty amazing. We found that companies really liked the accelerator. They gained a ton of knowledge. So it was a big time commitment. And for a startup, we recognize that that's hard. We recognize that saying, hey, you need to give 1 to 4 hours of your day every day for the next 4 weeks to this program, that's a big commitment. But if you make that commitment, you're going to get real value out of that. And that's what we found. We found that the companies really found that they gained knowledge that they would not have gained otherwise, and that they are going to implement some of the things that they learned in the accelerator program. And I'm going to share this quote from one of the participants, Helen Grainer. I worked with Helen years ago. She was the co-founder of iRobot. She is now the CEO of Turtle, and Turtle is a company that is doing a weeding robot for your garden. It's a personal weeding robot. It's a very small robot that is solar-powered, goes out in your garden during the day, weeds by essentially using, it has like a little weed whacker, if you want to think of it, a little blade that goes by. And what they found is that if you cut down a weed every day at a small height for a couple of days, the weed just gives up and it dies. It doesn't have the energy to continue that. And so it does not use pesticides. It does not use anything else. It just uses a simple little weed whacker. But the system is smart enough to be able to go around, avoid up. They've got some tools so it won't whack your tomatoes or whatever else you're growing, but get rid of all the weeds. And she went through the program, and I was wondering, why? Because she's already had a very successful company that went public. But it was her attempt to stay current and understand what's happening. And so she went through the program, and this is the quote that she gave, which I think is really interesting because it shows that virtually anybody can gain from a program like this. So I'm really excited to announce that we're going to run the cohort again. It was so successful that we've teamed again with Amazon, AWS, and we're running the AWS Robotics Accelerator. Applications are opening today, and they will be open for the next about a month. And we encourage you, if you're a startup here, if you know startups, we encourage you to please share and have them apply. The application process is really pretty simple, and it does get you the ability, if you are selected, to be in this program and to meet some amazing folks from across the industry. You'll meet leaders from Amazon, but you'll also meet leaders and CEOs and CTOs from other companies. I think we'll have the CTO from iRobot talking in one of our sessions. But you'll also have the ability to network with other startups, and that's an important part. Unlike other accelerators, we don't take any equity as part of this. There is no cost to you, just your time, your interest, and hopefully your excitement. So we're really passionate about this. We hope that you will sign up and participate in this event. So I want to share a little bit about Mass Robotics. We are, as I mentioned, a nonprofit. We're here to support the industry. We do that in a number of ways, but we're really driven to encourage the growth of young companies and to have them scale and deploy. In terms of the things that we do, there are 3 main areas. We advocate for the industry. So I mentioned earlier that we do standards. We're doing some work in that. We do some work in terms of legislative support, ensuring that there are good rules and regulations. We're working in an interesting area around sidewalk robots right now, which I think is fascinating. There's an effort to kind of manage sidewalk robots. I think people think right now that it's such an early industry, why would you care? But some of the municipalities, some of the cities are getting very concerned because they've had 2 or 3 startups say, hey, I want to run my sidewalk delivery robot on this section of sidewalk. And that's fine, 1 or 2 or 3, but all of a sudden if they have 4 or 5 or 6 robots on the same section of sidewalk, pedestrians are not going to be happy. And so they want to see how they can manage that. So there's standards that are being developed around that. And those are things we're involved in. I mentioned we help startups. We run a center in downtown Boston that's about 60,000 square feet of primarily lab space that we support and host companies and give them the tools to hopefully be successful. We give more than just space. It's a shared space, so it's kind of like the WeWork model. But in addition to that, we have resources around prototyping, so 3D printing, CNCs, laser cutters, vacuum formers, all sorts of tools to allow you to build your platforms. We also have a number of robots that startups can use. So rather than going out and maybe buying an industrial arm, they can use one of the 30 arms that we have, or platforms. We have a number of AMRs that can be used. We also provide software from companies such as AWS, and others like CAD software from Autodesk or SolidWorks or Onshape. We have other PCB planning tools and other software that the startups can have access to. And all of that is pretty much at no cost. So there's a lot of resources that you get, and we hope that you'll consider joining our facility. And the last thing is we offer STEM education. We have a set of courses that we offer around different tools. We offer a drone academy. We have different types of programs that people get excited about. In terms of our model for space, I wanted to just talk about this for a brief second because we're a little different. When you think of accelerators and incubators, they're at different stages for startups. So a lot of times an incubator will really be early on. If you just have an idea, it's a great way to get started. Accelerators, obviously their target is accelerating that, so taking you from concept to understanding how to build a company. We are actually a little bit later stage. We call ourselves an escalator, because the idea is we're going to take young companies and hopefully escalate them out to product in a successful manner. We see the companies join us that usually have a product idea and are really looking to actually build that into a product. They might already have a prototype, but they want to understand how to manufacture it, how to get customers, build revenue, build a team, get VCs to invest. And then they will exit and move on to their own offices. And so that's what we have, a combination of physical and strategic and ecosystem parts to our effort. We have 64 residents today, 65 actually. I gotta keep looking because we add. And as I said, companies sometimes graduate or move on or maybe aren't successful, but then we add new companies. So this is the current cohort of what we call residents or companies that are at Mass Robotics. And you can see they cover the range of kind of the robotics industry that I just talked about before. We have, I would say, almost something in every category. And some of them are really unique. So Tenabot is a robot that picks up tennis balls. So if you go out and play tennis, if you're a big tennis fan and you sit there with your bucket and you're practicing serving, the robot will go get them, collect them all, bring them back to you. So pretty unique. But also, for those who are really tennis fans, it's a big product. And it's not that expensive. It's a consumer product. So we see a bunch of different companies across the thing. I won't go through all of them, but there's certainly a range. And we see robots addressing almost every need across society. We are funded primarily by our support from our corporate partners, AWS, Amazon Robotics, iRobot, and some of the other players in the industry that provide both financial support, in-kind support, and mentorship, guidance, and so forth. So these are critical to our success. We're excited to have them on board, and they can help all of our startups. And one of the things I would encourage with startups is, as you look to build your companies, is to find connections, find ways. We're just one of a number of different clusters of robotics here in the US. There's a cluster in Pittsburgh, there's a cluster in Silicon Valley. Get engaged, talk to them, understand who they're working with, and find their inroads to your potential customers, and then go and talk to your customers. And when you think you've talked to your customers enough, go talk to them again, because you never have. And that's the biggest thing that we go and work with our startups on, is trying to get them in front of as many customers to really define their product better and make sure that they're a good product fit when they come out. We've seen too many startups talk to one or two customers, not realizing that those customers may be huge players, but only represent a section of the market. And if they had made some small adjustments to their product, they could make it much more viable across larger ranges. So that's a little bit about us and a little bit about the thing. I want to thank you for attending. And if you have any questions, I'm happy to answer them now.